This is a Brother EP20, a portable typewriter from 1983. I got this at a local thrift store, but I believe it was imported from Japan. As I take it out of the box, you can see that all of my documentation is in Japanese. Here we have a warranty card, a customer satisfaction survey, directions on cleaning the print head, and IKEA-like language agnostic instructions on how to load in your ribbon. You can also see how wonderfully tiny this typewriter is. As I remove the cover, it becomes apparent that my unit was cherished, but not used much. It is in mint condition and came with 3 nearly new ribbons. Since my unit was imported from Japan, the manual is in Japanese, but thankfully the previous owner printed out a mostly complete European manual. There are a lot of features crammed into this tiny typewriter. An LCD for editing before printing, a full set of extra characters on the keyboard, external power or batteries, and a built-in calculator. But I find none of those things to be its most unique feature. If I load some paper in and start typing, you'll see that this is a dot matrix typewriter. And not only that, but if you remove the cartridge and put in the right kind of paper, you'll see that it also supports thermal paper. Brother did produce packages of A4 paper to use with this typewriter, but I can't find any new ones being made, so for now I'm stuck with thermal fax paper. The use of a dot matrix printhead is what lets them have so many unique characters in such a small package. The EP20 is the first model in what would become a line of dot matrix typewriters made by Brother. Although they weren't against being an OEM for other brands, as the Silver Reed EX-D10 is clearly an EP20 in disguise. In 1983, when this launched, you had the choice between an EP20 or an EP22, which is nearly the same, but featured an RS-232 serial port on the side, which allowed its use as a standard computer printer. I believe all later models after the 20 and 22 retained this feature, making the EP20 the only model lacking an external input. Despite its diminutive dimensions, it's definitely a desirable device. So I think it's time we take a look at it in use now. Now the most important switch on here is going to be this one. This allows you to switch between no print, correction print, and direct print. No print does not use the print head. It's very useful when you want to do calculations and don't want to print the result. Correction print waits until characters would fall off the edge of the display and then puts them onto the paper. So if I type a bit on here, when I start to type the next thing, it starts to put it on the paper. You can also press clear and it will print the remaining text in the display to the paper. Direct print makes this function as a typical typewriter, and anything you type goes to the paper. Margins and tabs on this device are fairly interesting. If we space over a little bit and press left margin, that sets our new leftmost side. If we press enter, we will stay at that side, and when we go back, it will return to that side always. We can also space over and set a maximum right margin. This means as we approach that point, it will beep and eventually stop us. Now, if you need to keep printing after you've hit the margin, you can press this key to override it. However, it will maintain the margin for the next line. And if you need to clear those margins, you can either go to the extremes of the paper and set a new margin, or just restart the printer. Now, I find tab set to be fairly interesting on this device. If we space in 4 spaces and tab set, then space in 8 spaces, do a tab set, space in 2 spaces, and then return. As we press tab, we will go 4 spaces, 8 spaces, 2 spaces, and then to the end of the paper. It can hold 16 individual points along the page to use as your tab stops. I'm not sure if that's a common typewriter feature, but this is my first time experiencing it, and I think it's pretty cool. Another cool feature of this typewriter is that it is whisper quiet. Let me move the microphones down here and type on it a bit to show you. You'll have to forgive any typing mistakes I make on this. The keyboard is rather small, and I don't want to do multiple takes because the ribbons are nearly impossible to get a hold of, and I would have to throw away large portions of thermal paper after cutting it off to get a clean shot. I think that covers just about everything we can do on the outside, so let's crack it open and take a look inside now. A word of caution for anyone who decides to get one of these: the power input is 6 volts at 1 amp, and it is negative center. So I'm using a small adapter for a power supply I already had. Now the power supply I'm using is actually 5 volts, capable of delivering 2 amps. So it will run at a lower voltage. I did try it with a 5 volt battery bank, but it didn't seem to be able to provide enough current for the thermal print head to sufficiently heat the paper. So if you want to use this portably, you're probably best sticking some D batteries in there. This thing is really nicely built. All of the screw holes have metal inserts, so the threads have something to bite into that isn't plastic, and all of the screws have washers on them so they don't damage the plastic when you tighten them. That's a nice attention to detail there. Alright, now let's see. Oh, that didn't sound fun. I see loose hanging springs on the sides, and yeah, I think this was a bad idea. Alright, so it appears the locking mechanism is held in place by the top case. So don't open this upside down. A few springs have fallen down, and it looks like metal bars should go here and attach the springs to this to allow this to lock back in. So now I need to trace those parts down. Should clearly be looking for some... here's one. Metal bar. Now there should be one more of those. Well, I tipped it back like that, and the other metal bar fell out. Excellent! So we have all the pieces we need again. Alright, now that the mild crisis has been averted, we can take a look around here. So we can see the buzzer that allows it to beep. We have an end stop sensor here for the carriage. We have what appears to be a basic board that handles the power supply and control for the motors. And over on the keyboard, we have most of the logic, because we have the LCD down here, and we have to scan the keyboard matrix, and we have a calculator function built in, and it can go back and do correcting, so this thing is fairly complicated. One thing I really like about this printer is that it does not use a belt to move the print carriage. It has this metal wire with a spring down here for tensioning, and this is going to last a lot longer than any belt is, let me tell you. My fingers have been dirty in this video because I just worked on the belt for a reel-to-reel player, and ooh, that was a joy to change. So, seeing this makes me pretty happy. Well, without taking the keyboard PCB off, I don't think there's much else to see here, and I don't really think this is going to lead to much more excitement. So I'm going to go ahead and put this back together now, which is going to be a little bit of a challenge since the print head assembly started to fall apart without my knowing. Alright, the first spring is on. Alright, now let's put the second spring in place and attach it to the print carriage bar. Ah, much better. There we go, back together and printing happily. Well, that pretty much wraps it up for the tiny little EP20. I hope you guys enjoyed that look at an interesting little typewriter. And when I say little, yeah, it's a lot smaller than my other typewriters. It's amazing what a difference in design choices would do. Wheelwriter's definitely a lot more satisfying to use. But for now, that covers everything I wanted to say, and I'll see you guys next time.